start. All right. I think we are good to go. Right, perfect. So I'll just start once again and give you all the intro about the very purpose of this class. Before that, I'll quickly take a minute here to introduce myself as well. My name is Riya Bansal, and I'm currently working as a software engineer at Flipkart. And previously, I have worked at many other companies as well, such as American Express, Amazon, InterviewBit. So I do have a lot of teaching experience, and I am really passionate about teaching. I have been taking a lot of classes already on both YouTube and Unacademy, right? Which you can always just go ahead, and they're all recorded videos available over the internet, so you can always just go ahead and watch them if you want. Apart from that, we have launched a series of micro courses. Like the name suggests, micro course, it is going to be a small course where we pick some important topic which is which is very important from the perspective of interviews and competitive programming as well. And keeping that in mind, we try to design 3 to 4 classes, and they're designed in such a manner that we try to cover the most important part regarding that topic, or as a thing that you should be knowing about that, and we try to scale you from the very beginners level to the advanced level. So in this micro course that is named on segment trees, we're going to be talking about a data structure that is going to be trees, and from that we come to the part of segment trees. And here we'll start from the very basic part. This class, I'll just set the agenda also for the class today. This class is going to be based on the very basic topic of how exactly you should look at segment tree, what purpose does segment tree solve, why do we need a segment tree, and how do you build a segment tree of your own, right? So that is the overall idea behind this class. Once we had that gist, and once we have that understanding of why exactly this is required, right, why this data structure is actually required, then just give me a second. Right, so once we have an idea of about why this data structure is required, then we'll move on to the next next 2 classes, which will be based on beginner to intermediate problem solving, where we will solve some basic questions and some good questions on segment trees, and the third class will be based on advanced problem solving, right? So I have designed the course in such a way, I have designed the content in such a way so that we are able to take full advantage and increase our knowledge in that particular aspect, right? You can always just have, if you miss any class, let's say 1, 2 or 3, any class that you miss, you can always go ahead and watch the recording as well. Yes, Kartike, that is what I was coming to, that you can always just go ahead and watch any of the videos that you want, right? So that was the overall idea behind it and the overall motive for these classes as well, right? So without wasting any time, I'll just quickly start the class today, and we'll cover the topic that is supposed to be covered today. One small thing that I say in each and every class, and then I expect all of you to help me in that perspective, is that please make sure that you do have a thumbs up emoticon in your chat. So if I'm teaching anything, and if any part is absolutely clear to all of you, please make sure you make use of that thumbs up emoji, so that I know that whatever I'm trying to teach is being conveyed to you or not, right? So that is just small thing or small way that I use to acknowledge the fact that everyone is clear with what we are trying to discuss, right? If it is clear, just put a thumbs up so I know that the majority or all of you are clear, and we can move ahead to the next part. If you have any relevant doubts, please make sure to put it in the chat. I will not be able to see the chat simultaneously, right? But we do have a teaching assistant present who will be taking over the doubts as and when they come in the chat, right? So please feel free to ask any doubts that you want, right? And please don't feel hesitated to engage from any kind of questions that you have, right? Okay, I'll just quickly start sharing my screen, right? Let me know if it is visible to you or not. Then we'll quickly go ahead. I hope everyone can see the screen. Alright, perfect. So let's just quickly go ahead and start, right? I'll start with a very basic idea and a very basic problem statement, and from there we'll try to see what concept and what logic building can we do from there, right? Okay. So we'll start with a very basic problem statement, right? I'll give you a problem and let's figure out a few ways to solve that problem, right? Okay. So the question to us is that given an array, right? So you're simply given an array. As a prerequisite for this class, right? As a prerequisite for this class, I would expect you to know the basics about data structures like arrays. You should also have an idea about the data structure called trees, right? So that is what the overall idea is here. So given an array, let's say it contains these elements. So there is no constraint on the type of the element that can be in this array. Now there are two types of queries that are given, right? By queries you can basically say two types of operations that you will have to perform, right? So it can basically be of two types. The first type will be the range sum query, right? What exactly does that mean is that I will simply give a range, right? I will simply be saying that given a range that, let's say, looks like this, I will write range, I will write the start and the end of the range, right? So I will be denoting the start of the and the end of the range, and you have to do the sum of all the elements in that range. Example would be, let's say I do r0, 2, then it will be 10. Why? Because I will simply do 1 plus 3 plus 6, right? That is starting from the very 0th index till you go to the second index, right? Let's say if I simply call you r1, 3, so that is going to be 9. So that is one kind of query that can come to you, right? And the second kind of query that can come here is going to be an update query. Now what exactly does that happen is, you will have this kind of query, you will have an index and you will have a value, correct? So what you have to do here is, let's say the index is 3 and the value is 10. So the task that you have to do here is, you basically have to replace element at index 3 with 10, correct? So that simply means that if I do this, that means on this index, instead of 10 I will get instead of 0 I am simply going to get a 10, right? Now one important thing that you should know here is that these queries can come in any order, right? Either, let's say you first get a range sum query, then you get an update query, then you get a range sum query, then let's say you get update, then you again get update and update, then range. So there could be any ordering, right? Let's say for this example that first I got this query, right? Let's say then second I got this query. Now let's say third I get this query, 2, 2, 3, right? So now if that is the case, now the answer will be 6 plus 10 is equal to 16, right? So that is what the overall question is. Does this question make sense to everyone? Just first give a thumbs up that the question makes sense or not, then we'll move on to the next part. Right? Perfect. Now think of a way how you can solve this problem, right? Any basic approach will work. Please don't jump directly to an optimized approach. I will help you to that process of how exactly going from a brute force approach to an optimized approach, right? So that will be my job. I just want you to have a thought process and to keep thinking throughout the class. I'll give 2 minutes, 2 to 3 minutes for each and every one of you to think, then we will move forward. See if anything strikes you as an approach to solve this question. I've given a few examples for your reference as well. So try running on a few cases, then we will discuss. Okay, Akash, yes, that is a valid way to go about it. Anything else or anyone else wants to share an approach to this that you think would be a useful way to go about this problem and to basically, have a thought process? Okay. Yes, Ishani, that is also a good approach. Just make sure you understand that there are two processes at play here, and you have to try and make sure that both of them are equally optimized. Correct. Kuldeep, yes, we can do that. Now take a minute here and try to analyze the complexity of this process and see how optimized or unoptimized this process is. Anyone with any clue, anything that you feel would be useful here? Alright, let's discuss. Let me give you a thought process around it, how you should be or how I would have gone from the very basic approach to a kind of an optimized approach at that particular point of time, right? I'll just, Ashish, I'll just quickly go through the question once again and I'll help you through the process after that. So the question is that you're simply given an array. It can contain any elements. There is no constraint as such on that. Now there are two types of queries which can come. It can be a range sum query in which you will be simply given a range and you simply have to tell the sum of all the elements in that range. So that is what the overall idea is. The other query which can come here is that you will be given an index or you will be given a value and you have to simply update that index with the value which has been given. So if I do a 3, 10 as an update query, so at the third index I will put a 10, right? So that is what the overall idea is. That is what you will have to do here, correct? Both the I think queries are very simple. It's just that both of them can come in any order, so we have to be careful with the process that we choose, right? Okay, now a very simple approach, and I can say a brute force approach also to solve this question. Simply can be that for the range, so if I have to find the sum of the elements in a particular range, I can simply go through it by a for loop, right? So I can simply do that for the range query, right? I'll simply iterate, let's say from I equal to s, I less than equal to e, I will do I plus plus, right, and I will do sum equal to this, right? Simple as that. Whatever range you will give, I'll simply get the answer. For the update query, since I told you that we have an array, right? So if I am, let's say, given an index and a value, so let's say if this is the array ARR, I can simply, or let's say A only, I can simply do this. And this is enough for doing the updation operation as well, because in an array we have random access, so I can simply go to any index that I want and can update the value of that particular index, right? So that is the overall idea. Now let's take a minute here to see the time complexity of that process as well, right? The time complexity of that process and how complex this process is, right? So since I am applying a loop here, in the worst case I will have to iterate over the whole array, so the time complexity of this process can be order of n, where n is equal to the length of the array, right? And here, since this is an update operation which is constant, time complexity is order of 1, right? Now this process is actually very easy, right? And this should be expected, and it is expected that you should know the brute force approach, right? The very reason we call it brute force is that it is expected that you know the overall idea behind this approach, right? Now there is another approach to this as well, right, which many of you did put it in the chat. So let's just try to see how approach or how effective is that approach, right? So the overall idea is that you keep a prefix sum, right? You simply keep a prefix sum to solve this particular question, right? Now what exactly is the prefix sum? If you know the concept of prefix, that is basically subsequent characters of a string present at the start, right? So if I simply say that the array looks like this: 1 3 6 0 10 7, and let's say I have a array P, which is the prefix sum array, right? So it will have the same number of elements. Now at this point I will store the sum of the elements till here, that is 1, correct? And here I will store the element of these much elements. So here I'll simply store a 4, right? For all the elements here I will store it here. So till that particular index, till the start, I will store the sum of all the elements, right? So this should ideally have been 10, then we have again a 10, then 20, then 27, right? So I am keeping a prefix sum array here. Please make sure you understand the sum of prefix sum array. If there's any doubt in that, please make sure you ask it, right? So what are we simply doing here is, at a particular index I, we store the sum of elements basically from 0 to I, right? This is what we are doing, that for each index we are simply storing the sum from the start till that index, right? So now for simply getting we're talking about first here the range query, right? So for simply getting the range sum, what I can simply do is, let's say if the range sum is given to be s comma e, so I can simply do prefix of e minus prefix of s minus 1, correct? The idea is again very, very simple. Let's say if I have this, correct, and I have to find the sum of all the elements from 1 to 4, correct? So this index 0 1 2 3 4 and 5, so this index is storing in the prefix array, it is storing all the sum of the elements from here to here, right? So from this point, if I will simply remove this sum or this particular part, what I will get the sum of all these elements, correct? pretty evident here that if I have the sum of all the elements from here to here, simply deleting the sum of all the elements here will give me the sum of all the elements here, and this is for the prefix array. So that is what we are doing here as well, right? And what is the time complexity of this approach? This approach comes out to be a order of 1 approach, right? In terms of time complexity, this approach is pretty efficient, right? And it gives you order of 1 complexity for solving this question. Once you will have to do this task of order of n to basically find out the prefix sum, but once you have done it, each operation of range sum is going to be having a complexity of order of 1, right? So that is what the usual thought process is when student thinks about an approach to solve this question, right? But a few problems, and I can say a few things that we should be considering while looking is that what will happen in case of an update query, right? Let's say now in this part you have to do an update of the 4th index with the value 6, right? So effectively what will happen here is that this value will become 6, but now since this value is becoming 6, all the prefix sums after here will be affected, correct? अब देखो यहाँ पे you will have to change the prefix sum. Now at this particular point, instead of 20, the value here will be 16. Instead of here 27 value, the value that is actually going to be here is going to be 23, correct? So that is one issue that we have to solve here, right? We cannot have the same sums at this point, and you will have to keep updating the prefix sum array, because after this you can get a range sum query and it will be very difficult to solve it. So although you see here that we did optimize on the range sum query, but for the update query, in the worst case, the time complexity can go order of n, right? I can simply say if the value of I is equal to 0, right? And let's say I do 0, 3. Now in this point, this sum will be getting affected to 3, and all the prefix sums after that will also be getting affected, right? So in this case, I can simply say then all prefix sums will be affected here, correct? So that is what the overall complexity of the two approaches is, right? Now is this part clear of discussing the complexity of both the approaches, the brute force approach as well and the second approach? First tell me that part and then we will move forward. Of the two different approaches. Yes, Ravi, both the queries will be in the same question. Adarsh, so you don't know which query will come when, right? It might happen that suddenly you have the range query and then you have 5 updates query, and then a range query can step in and then update query can come. So the queries can come in absolutely any order. You do not have any control on that. Sanket, what we are simply doing here is we are keeping a prefix sum, right? Prefix sum is simply the definition I have stored and explained here as well, that at each index in another prefix sum array, I am simply storing the sum of all the index starting from 0 till that sum, right? So here you can say that if it is 1, 3, 6, so at this index I have stored a 10. This is what I am maintaining, and the purpose of maintaining this prefix sum array is that the range sum query becomes quite efficient, right? It becomes an order of 1 operation, right? It becomes an order of 1 operation because here you can simply use this formula to get your answer for the range sum. But what we saw here was that the downside is that although you do update the range query, but you have to compromise on the update query, right? Here the update query does not get optimized, and in the worst case the update query has a complexity of order of n, right? So this is something that you have to make sure of, right? something to keep in mind, that although you may optimize on one query, the other query might get affected, right? Akash, that will be already given to you, and that will obviously modify the scenario for that question, right? For this question, we are assuming that you have to do an update query and a range query, right? For probably in case of a multiplication and addition, you look at a different approach there. Mayank, for what type of query are we looking here? The two pointer method. Mayank, in the second approach, if you look here in the range sum, in the second approach you do not need any pointers here, right? And even if you do use the pointer approach to solve this question, that will not be optimized, right? The most effectively you can do the range sum part is in order of 1. So that is the most optimized way if you are using 2 pointers, which I think will work, but still it is not an optimized way to do it, right? Okay. Now let's try to see how exactly and how we can step in here to solve this problem in a more optimized manner, right? So what we saw here was we had two approaches. We had an approach 1 and we had an approach 2 as well, right? And we were having some operations as well. So we have the range operation and we have the update operation, right? So in approach 1, although this was an operation of order of n, this was an operation of order of 1, but in the other part this became an operation of 1 and this became an operation of order of n, right? Okay, Shubham is saying, ma'am, how do we modify the prefix sum array after an update? That is very simple. Shubham, what you can do is, let's say this is your prefix sum array 1, 4, 10, 10, 20, 27, right? Let's say now the case comes when you have to update the second index with the value 3, correct? So you have 1, 2, 0, 1, 2 here, and here the value becomes 3, correct? So what you will simply have to do here is, you see that you have 10 minus 3, that is equal to 7, right? This is actually what comes out to be here. So what you're simply going to do is, you're going to make sure that you follow the same pattern everywhere. So you have simply deducted a sum 7 from the value, right? So this value is basically getting affected here. So you will have to make sure that you take care of that sum everywhere as well, right? So you will make sure that you are reducing the 10 sum, right, but you are adding 3 here. Similarly in here as well, you have to make sure that this particular part, because this is the value which is storing sum till here, right? So if this particular value is changing, so you are deducting minus 10 and you are adding 3. So these are all the sums, that is 1, 2 and 3, and this is the value which is basically be getting affected. So you will have to update all these queries or all these values in the prefix sum array, right? Now coming back to the point of how exactly we looked at both the approaches here, that actually if you basically take a close look here, you get to see that none of the approaches are optimized, right? We basically want to do something better, right? Now don't you think if there is an approach, right, which comes up that says that actually does this work in log n and also this work in log n, don't you think that will be a more optimized approach? How many of you feel that if somehow we can come up with an approach which can solve both these queries in a log n operation, that will be more optimized compared to approach 1 and approach 2? Does that make sense to everyone? That will be a better approach? No, Samrat, in that case we have order of n for an update query, right, in the second approach, right? So that is one way to optimize this particular question, that somehow, ab mujhe nahi pata how will I do this, but there is a way to simply acknowledge the fact that if I can somehow do both these operations in login, then that is like a good good optimization that we do here, right? Now I want you to develop this thought process, and I'll do this in the same exact way. Right now, when you hear, or let me just frame the question here, what algorithms or structures come to your mind when you hear time complexity of login? Now I want all of you to answer this. जब आप सुनते हो a complexity of login, what exactly are the approaches, what exactly are the algorithms, different structure that comes to your mind when you hear that? Let's say there is a particular process which has a complexity of login. What are the different things that come to your mind? Okay, I see, very good. That is definitely a right way to go about this. Okay, correct. Many of you are correct and actually giving the right answers as well, right? Whenever I hear about a complexity of login, the things that comes to my mind are binary search, right? I also get the idea of somewhat like a divide and conquer approach, right? Something we are dividing simultaneously, let's say by two parts, and then we are doing this. And we can also say balanced binary search trees, right? Or simply binary search trees as well, because in binary search tree, at from each point you either go to left or right based on the node values, right? Correct. So these are a few things which come to my mind when I hear about a complexity of login, right? Now what do you think, what is common in all of them? What do you think? Is there anything that is common in all these approaches? Correct. Very good. I actually expected this answer from everyone. The thing that is common between all these things are that we basically divide the search space in each iteration here, right? In each iterations, we basically try to divide our search space into smaller part, right? Now what we will think is, we'll try to think of a similar approach here to solve our problem as well, right? अब हम क्या कर रहे हैं, थोड़ा सा reverse engineering कर रहे हैं, right? We know what complexity is ideal for our question, and somehow we are trying to come to that complexity, right? That is what our ideal approach is here. ठीक है. सो अगर मैं अपने क्वेश्चन को देखूं, मुझे क्या करना है, एक सर्च स्पेस चाहिए और मुझे डिवीजन करनी है और कुछ उस सर्च स्पेस पे, राइट? सो अगर मैं क्वेश्चन देखूं अपना, फॉर द अपडेट एंड द रेंज सम क्वेरी, आई कैन सिंपली से इफ़ आई हैव टू लुक फॉर अ सर्च स्पेस, तो वो मेरी रेंज क्वेरी होती है, राइट? मुझे क्या करना होता है, एग्जैक्टली मुझे एक रेंज दी होती है एंड दैट इज़ माई सर्च स्पेस, करेक्ट? इनिशियली मेरी सर्च स्पेस इज द एंटायर एरे, है ना? ठीक है. एंड व्हाट आर वी सर्चिंग हियर? अगर आपके पास कोई सर्च स्पेस है तो यू मस्ट बी सर्चिंग फॉर समथिंग. What are we searching here? वी आर सिंपली लुकिंग फॉर अ टारगेट वैल्यू, है ना, यही हम कर रहे होते हैं, दैट वी आर लुकिंग फॉर अ टारगेट वैल्यू इन दैट पर्टिकुलर सर्च स्पेस. एंड व्हाट इज दैट टारगेट वैल्यू? आर टारगेट वैल्यू इज द सम ऑफ द रेंज according to our question, right? Now this is what the whole process is. Now we can simply say here, so my idea would be similar, that if I have, let's say, the whole array starting from 0 to n, right, n is the number of elements, I will follow the same process of somewhat dividing it from 0 to n by 2, right, and here also I will do n by 2 plus 1 to n, right. Similarly I will keep on following this from 0 to n by 4, and then again n by 4 plus 1 to n by 2, and I will simply keep on doing this till I only have one element left. So it will be simply 0 comma 0, 1 comma 1, 2 comma 2, 3 comma 3, right? So this is what my ideal thought process is. This is what I would ideally like to achieve, that मैं हर iteration में search space को कुछ half divide कर दूँ, right? And this is how I try to basically go through the entire process and just try to solve this question, right? अगर मैं ऐसा कुछ कर पाऊँगी, right, if I somehow am able to do this, then I can solve this problem very easily, right? Now what I already know is, right, are these values, correct? अगर मुझे एक array initially दे दो which contains, let's say, 1, 3, 6, 0, 10 and 7, so I already know all these values, correct? मुझे पता है कि first index पे क्या है, second पे क्या है, third पे क्या है, and simply moving on forward, right? This is what I already know. So what I will do is na, right, I will build a tree kind of a structure here, right, where each node I will just write this down so that none of you forget it. Tree kind of structure here where each node will represent a sum of some segment. हमें नहीं पता कौन सा segment, but it will represent some segment, right? Now whatever I am going to explain to all of you, right, just understand the concept, right? Implementation भूल जाओ, implementation कैसे होगी. Many of you will find it difficult also कि right कि मैम the concept is clear but implement कैसे करेंगे इसको, right? So don't forget about that for a minute, right? I will explain that concept also in detail, but the moment I explain the implementation and the entire process, for that time just forget about implementation, just focus on the concept, right, how the concept works, and after that we will come to the implementation as well, right, of how exactly the implementation will go. So what I will do is I will have a root node which will basically denote the sum of the entire range. Let's say I have an array this 1, 3, 6, 0, 10 and 7, right, and I simply have 0. These are the indexes. So I will do this. I have a tree here where the root node denotes the sum from 0 to 5, right, and then here, like I said, हम division process कर रहे हैं, so this is the sum of the nodes, right, sum of the nodes from the range. So this basically denotes the range from 3 to 5. Then we have the sum of the range from 0 to 1. Then we have here from 2, 2 because मैंने divide किया है, so I am using that mid formula, left plus right by 2. So this is left, this is right, and this is how the division will go on, correct? And this is how the division will go on. Alright, now tell me, you have to fill up this entire tree, correct? Now first tell me, what are the nodes for which you already know the answer? What are the nodes for which the answer is already known to you and can be calculated in a complexity of order of 1? Leaf nodes, right? For leaf nodes, I already know the answer, that here the answer will be a of 0, here the answer will be a of 1, right? Here the answer will be a of 2 and here the answer will be a of 3. So I can simply fill these values. Correct? Now don't you think if I have to find the sum from 0 to 1, I can just simply add the values from the left and right child, and that will simply give me the value of the current node. So can I not just simply get 4 here, which was 1 plus 3, correct? I can simply do 0 plus 10 and this will be the answer for the range 3, 4, right? I can simply do 10 plus 7 and it will give me 17, that is answer for this range, right? And I can simply do 10 here, that is 4 plus 6, right? And I can simply do 27 here. So this is what a kind of a structure that I can simply follow here very easily, right? And this is what is called nothing but a segment tree, right? Why exactly do we call it a segment tree? इसके दो reason है. Because it is a tree data structure, which is pretty obvious, correct? The second reason we call it a segment tree is because each node is representing answer of some segment. देखो, in this tree, each and every node is basically, I can say, telling you the answer for some segment. अगर आपको निकाल, not all the segments but some segments. Let's say if I have to find the answer for the range, let's say 0, 2, right? So what I can simply do, I can just simply go to this node and say that my answer is 10 because it matches the range, right? So each and every particular node is basically depicting the answer to some range, right? First tell me if it is clear how to build a segment tree. Then we will move to the part of how exactly you are going to do the range and the update query here. But first tell me if the part of building the segment tree is clear to everyone or not. Sanket, like I said, we'll talk about the implementation. First, we'll try to understand the concept here only, right? All right, perfect, right? Rohit, we are using the same formula only, left plus right by 2. Margani, we'll come to that, don't worry, right? I have just told right now how to build a segment tree, right? I have not told you the answer how to query in this segment tree, right? So that part is going to be covered now. Now, the most important part is that once you have built a segment tree, how to use this segment tree effectively, right? That is what the whole idea is. So let's so we had two operations, right? We had an update operation and the second was an range sum operation, right? So एक काम करते हैं, first let's take the update operation. Correct. Let's say I simply have to do the update of 3,5. Correct. So that means this is representing the index and this is representing the value to which I have to update it. Correct. So process is very simple. What I can do is, we know that we start a traversal in a tree from the root node. Correct. So I can go to the root node and I can check its range. Correct. And I can also check the middle value. The middle value comes out to be 2, right? And I have to update the index 3. Matlab, it is definitely sure that that particular I can say node is going to be present in the right subtree. है ना? Because here we only have the range 0, 2. So if I need the index 3, which is being asked in my question, the answer will definitely exist in the right subtree. Correct? Now what will simply happen is, let's say now I will follow the same procedure. I am currently at range 3, 5. I am looking for this index and here the mid comes out to be what? 3 plus 5 by 2, which is 4. Correct? So definitely I can say that my index will exist in the right subtree because it is in the left part. Now I am at here, this is the value and the mid comes out to be 3 and 3 is also the index that I am looking for, so I can simply go here. Correct? And now you will see that the range is 3, 3 and you are also looking for 3. So this is the part where you need to do the updation. So you will simply remove it from here and you will do 5. Correct? You will simply remove it from here. You will simply put a 5 here. Now when you are simply iterating the tree, right? You know iterating the tree is a recursive procedure, है ना? अगर मुझे ट्री को iterate करना है तो that is kind of a recursive procedure, even if you use in order, pre-order or post order, right? So now when you are coming back ना, you will start updating the sums also. अब अगर यहाँ की value 5 हो गई है, so now this becomes 15, correct? Now when you come back from here to here, now if it is 15 plus 7, this becomes 22, correct? And when you come back from here to here after the tree traversal, this becomes 32, correct? First tell me if the update operation is clear to everyone. That you simply check the node range, you check the middle value. On the basis of that, you simply take a decision whether to move left or to move right. Rohit, the underlying idea of binary search and segment tree is same, that basically based on the mid value, you take a decision either to move left or you move right. Right? That is what the overall idea is here, that based on a particular middle value, you simply move to left or right. Correct? Ravi, what part is not clear? Okay, I'll just explain it once again. Let's just take one more particular node. Let's assume I have to do this update operation. एक और example लेते हैं. Let's say the second update operation that I have to do is on, let's say, second index, I have to update the value with 10. Right, this is what the overall idea is. Now I am simply here, correct? If I have to do the operation, I will traverse this tree and make an update. Now if I am here, I will check the range of this node, correct? तो मेरे को अभी ideally करना क्या है? There is a node which is representing 2, 2, right? On that node, I have to put the value 10, correct? So for putting the value 10, I have to find this node. The first step is find the node 2, 2, correct? Because on that node now you will put the value 10. So now if I am currently here at 27, right, if this is representing the range, the mid value is 2, and if I have to update the second index, then definitely it will exist on the left side, because left side depicts 0, 2 and right side depicts 3, 5, correct? So that is why I will move to the left side. Now I am currently here, right? Again I have to find the index 2. Now on looking at the range and taking the middle value, mid value comes out to be 1. That means definitely the answer is in the right side, correct? So when I come here, I see that this is the required node that I was looking for, right? This is the required node I was looking for. So simply here now the new value will be 10. So update, the second step will be update the node, correct? So here now this value becomes 10. बट अब देखो अगर ये वैल्यू 10 हो गई है, करेक्ट, अगर ये वैल्यू अब अगर 10 हो गई है, तो मैंने क्या कहा था, जो आपकी करंट नोड का सम होता है वो आपके चाइल्ड का सम होता है, करेक्ट? तो इफ़ आई हैव टू से हियर 10, तो वो 10 क्यों था, बिकॉज यहाँ पे वैल्यू 4 थी और यहाँ पे वैल्यू 6 थी, करेक्ट? बट अब अगर मैं यहाँ की वैल्यू को 10 कर दूंगी, देन द रेंज ऑफ द सम 0 to 2 विल बी अफेक्टिव. इन अ स्मॉल एग्जाम्पल, अगर यहाँ पे कुछ सम था, लेट्स से इन सब का वैल्यू 10 था, द सम ऑफ ऑल दीज वैल्यूज़, अगर मैं इस वैल्यू को अपडेट करके चेंज कर दूंगी विच इज़ एट द सेकेंड इंडेक्स, तो ये सम भी अपडेट होगा ना. तो दैट इज़ व्हाट आई हैव टू डू. अब मैंने वैल्यू तो अपडेट कर दी, बट अब जो रेंज सम्स हैं वो भी मुझे क्या करने पड़ेंगे, चेंज करने पड़ेंगे. सो व्हाट विल हैपन इज, अब यहाँ पे द सम विल बी 10 + 4 विच इज़ 14, right? And यहाँ पे it will be simply 14 + 22 and that will be the sum. Instead of 32 I will simply put this part, that is 36. तो आप क्या कर रहे हो, you in the third step you simply update the range sum of affected node. Rohit, if I have to update value at the index 2, तो definitely जो node represent कर रही होगी वो 2, से होगी ना. That is what the overall idea is. So once you have reached this node, you can simply say you can update it. Like I am saying again and again, for the time being आप ये भूल जाओ कि इसकी implementation कैसे होगी. Just assume that somehow you know this fact कि कौन सी node क्या range depict कर रही है. We will come to the implementation, right? I will also tell you कि इसकी हम implementation कैसे करेंगे. I will show in the IDE also, but just understand the concept here. Does that make sense to everyone now? How does the update operation work? What is the overall idea? I have explained it step by step as well of how exactly we are going to put it, right? ठीक है. And what do you think is the time complexity of this update operation? That means the total number of updates that I might have to do. Correct. The time complexity here is going to be log n. Why log n? Because you will have to maximum iterate to the height of the tree, है ना. अगर आपको कोई वैल्यू अपडेट करनी है एट अ पर्टिकुलर इंडेक्स, तो आप वो यहाँ पे अपडेट करोगे हमेशा, है ना, at these particular nodes, and the maximum level of this node can be height, which is log n, correct? So that is what the overall idea is, that the time complexity of the operation of this operation can go up to log n, correct? तो हमने क्या करा, we have updated one operation as of now. Update operation को we have come up to a complexity of log n, right? Now let's see how we will take the range operation to a complexity of log n, right? अब वो देखते हैं that how does the range operation work here. अब मैं रेंज ऑपरेशंस को ऐसे समझाऊंगी सो दैट वी टेक ऑल टाइप ऑफ केसेस एंड देन वी सॉल्व द प्रॉब्लम हियर, ठीक है. Now for the range queries na, how I would like to classify it is that there are three types of range queries. Yes, Ayush, for each query, for each update operation it is going to be login. For n update operations it is going to be for q update operation it is going to be q login. Right, so तीन तरीके की queries हो सकती हैं in type of range. Correct. One type will be of complete overlap. इसका एक अगर एग्जाम्पल ले तो इट कुड बी 0 to 5, है ना. एक कंप्लीट ओवरलैप क्या होता कि लेट्स से आपको आंसर चाहिए 0 to 5 का और आपको पूरी की पूरी नोड वही सम रिप्रेजेंट करती है. करेक्ट. वन गुड वे टू सॉल्व दिस प्रॉब्लम इज, जो कि एक आइडियल केस होता कि भाई अगर आपको आंसर चाहिए 0 to 5 का तो एक नोड है जो पूरा का पूरा वही रिप्रेजेंट करती है. तो आप क्या कर सकते हो, सिंपली एट दिस पॉइंट लेट्स से हम अज्यूम करते हैं कि ये वाला अपडेट ऑपरेशन नहीं हुआ है, हमने सिर्फ एक ही अपडेट ऑपरेशन परफॉर्म किया था, ये वाला. ठीक है. कीपिंग इन माइंड वी विल सॉल्व दिस. करेक्ट. ओके. नाउ व्हाट विल हैपन इज, लेट्स से आइडियल केस क्या होता ऑफ अ केस ऑफ कंप्लीट ओवरलैप इन विच आपको आंसर चाहिए 0,5 रेंज का और पूरी की पूरी नोड वही रिप्रेजेंट करती है, या फिर आपको आंसर चाहिए 3,5 का और ये आपने पूरी की पूरी नोड रिटर्न कर दी. सो दिस इज द केस ऑफ अ कंप्लीट ओवरलैप. I will explain this particular case as well when I simply say that the range of the node is lying completely inside the range of the query. We can say that node is the answer. Correct. One more here case will be, let's say अगर array की range है 0 to 5, 0 1 2 3 4 5, and in that case अगर आपको आता है 0,7 तो भी आप आंसर 0,5 का ही रिटर्न करोगे. ठीक है. दैट इज द केस. जो आपकी रेंज क्वेरी है राइट, वो आपकी रेंज ऑफ नोड से बड़ी है. ठीक है. तो ओवरऑल आइडिया बस ये है कि अगर आप यहाँ पे -2 और 30 भी दे दोगे ना, तो दिस इज कम्प्लीटली द रूट नोड इज कम्प्लीटली इनसाइड दिस पर्टिकुलर रेंज. सो स्टिल यू आर गोइंग टू रिटर्न द आंसर फॉर 0,5. ठीक है. दैट इज वन केस सिनेरियो. The other case scenario is of no overlap. Right. In the no overlap kind of a scenario, right, let's say we have an array of 0 to 5 only, right, and the ranges that I am giving to you is this -7, -1. Correct. Or let's say I am giving you 7,11. So in all the cases you are going to be returning a 0 because this is the case of a no overlap at this particular point of time. Are these both cases clear? Then we'll move to the third case. Ask if there are any doubts at this point. Clear to everyone of how both these cases will be working? All right, perfect. So अब एक थर्ड केस पे जाते हैं which will be the case of partial overlap. Right. Let's say आपको ना आंसर निकालना था for the range 0,2. Correct. अब जो रूट नोड थी वो क्या डिपिक्ट कर रही थी, रेंज 0,5 है ना. जो रूट नोड थी इट वॉज डिपिक्टिंग द रेंज 0,5. करेक्ट. और आपको क्या करना है, आपको सिर्फ आंसर चाहिए 0,2 का. करेक्ट. नाउ दिस इज द केस ऑफ अ पार्शियल ओवरलैप, है ना, कि मतलब नोड की रेंज बहुत ही बड़ी है. द नोड इज रिप्रेजेंटिंग अ वेरी बिग रेंज. You just need a small part of that range, right? You just need a small particular part of that case, right? Now what happens in these scenarios is, एक काम करते हैं, let's draw the tree once again, then we will perform the query on that part. Right, let's say this is the tree and you have to basically perform or you just have to give a range sum of, let's say 0,3. ठीक है, and you have this. Correct, you just have to perform this. Now what exactly will happen here is that now you have to form the answer for 0,3, right? And you can see here that the range of the node is 0,5, which is a case of complete overlap. तो आप क्या करोगे, at this particular point ना, you try to find the mid value, right? Now for this the mid value comes out to be 3, right? The mid value comes out to be 2. So what you will do is you will say that from one part you get the answer for 0,2 because वो range यहाँ depict हो रही है. From the other part you simply get the answer for 3,3 and then you simply try to add both of those answers, right? You simply try to add both of these answers. Now what will happen is when you will come here, you will see that the range that you need is 0,2 and the answer from the left side you need is 0,2 as well. So now this is a case of complete overlap and you can simply return the value 10 here, right? Now you will also go to the right side because you need answers from both ends. Now again the range of the node is 3,5, correct? And you just need the answer from 3,3 here. Again you just need a small part, correct? You don't need the rest of the part. So again partial overlap का case हो गया. यहाँ पे again you will find the mid value comes out to be 4. ठीक है, तो when the mid value comes out to be 4, you know that the answer will exist on the left side only, correct? तो मतलब आपको right side जाने की कोई ज़रूरत ही नहीं है. अब यहाँ पे when you come again you have this range that is 3,4. जब आप mid निकालोगे तो mid आएगा 3. तो मतलब क्या चाहिए आपको, एक left side का आंसर चाहिए this. So again you move to the left side. अब यहाँ पे you simply see here this is 3,3, sorry, right? यहाँ पे you see that this is the range that you were looking for and it is matching as well with the current range. So in that case you will simply return the value here. So you will return 0, you will return 0, you will return 0. So from both ends, from the left part you get the answer from 0,2, from the right part you get the answer for 3,3, and when you add both of these ranges you get the answer for 0,3, which is 10 plus 0, 0, which is actually true in this case as well. The answer for the range 0, 3 or 0, 3 is actually, I can say here, to be turning out to be the same, which is 10. Is that clear to everyone? This was 4, 4, अगर ये 3, 3 है, 4, 4 is 5, 5. Clear how the concept works? Should be very, very easy, right? And if you can identify it, you should be able to see as well. Yes, Sanket, a very good observation, I would say. If you will look at here carefully ना, अगर आप carefully यहाँ पे देखोगे, it will always happen कि जो partial overlap का case होगा ना, the case of partial overlap will eventually drill down to a complete overlap or a no overlap. Correct. देखो यहाँ पे जब 17 था, आपकी रेंज क्या थी? 3,5. करेक्ट. आपको क्या चाहिए? 3,3. तो फॉर वन साइड आपको क्या ढूंढना है? 3,3 विच इज़ द कंप्लीट ओवरलैप, और एक तरफ आपको क्या ढूंढना है? नो ओवरलैप, क्योंकि कुछ रेंज ओवरलैप हो ही नहीं रही है. तो एक्चुअली आपके पास रेंज होती है, I can say somewhat like a partial overlap, but you eventually drill it down to a complete overlap or a no overlap. Ravi, you take that decision based on the middle value, है ना? अगर मुझे रेंज चाहिए 0,2, मैं करंटली हूँ 0,5 पे, अगर like I always said कि हमने डिविजन किया है मिड वैल्यू के ऊपर. अगर मिड वैल्यू 2 है, अगर ऐसे है, लेट्स से नोड की रेंज है 0,5, मिड की वैल्यू है m, आपको रेंज चाहिए 0 to m का सम चाहिए, तो आपको पता है ना कि वो हमेशा लेफ्ट साइड पे ही मिलेगा. तो बेस्ड ऑन दिस मिडल वैल्यू आपको डिसीजन ले सकते हो कि आपको लेफ्ट साइड पे जाना है या आपको राइट साइड पे जाना है. इज दिस पार्ट क्लियर टू एवरीवन? राइट. एंड यू विल सी हियर इन द वर्स्ट केस, राइट, अगर कितने केसेस थे? 3 केसेस थे. अगर कंप्लीट ओवरलैप का केस होगा तो आपको सीधा किसी एक नोड पे आंसर मिल जाएगा, है ना? वन ऑफ द नोड्स विल बी द आंसर. अगर नो ओवरलैप होगा तो आंसर ही नहीं मिलेगा. एक बस पार्शियल ओवरलैप का केस था जिसमें यू वर गोइंग इन बोथ डायरेक्शंस, है ना? You were going in both directions, but in this case maybe you will see that even if you are going in both directions, in the max case you will go to the depth of only 2 nodes here, right? So for the range sum query, the time complexity can go to 2 log n, correct? Why? Because you can go twice to the depth of the whole tree, and that is nothing but a log n kind of an operation, right? So that is what you can simply do here, and we can say that for the range query also, in all the 3 cases, the maximum I can do is going to be for a complexity of log n. Abhishek, if you have to call for 1,3, again that is very easy, right? अगर आपको पता है कि अगर मेरी current node 0,5 रिप्रेजेंट करती है, दैट इज़ द रूट नोड, और अगर आपको 1,3 का आंसर चाहिए तो आपकी मिड की वैल्यू क्या है? 2. तो दैट मीन्स आपको लेफ्ट साइड से क्या आंसर चाहिए? 1,2 का, राइट? और आपको राइट साइड से क्या आंसर चाहिए? 3,3 का. सिंपल एज दैट. तो फ्रॉम द लेफ्ट साइड यू विल लुक फॉर 1,2, ऑन द राइट साइड यू विल लुक फॉर 3,3. यू सिंपली टेक बोथ द आंसर्स एंड ऐड देम. करेक्ट? Does that make sense from everyone? I need a reply yes or a no on this from both ends. If that is clear. Markani, I'll clear that. Just give me a minute. Let me take like a generalized example. Let's not take a value example. एक generalized example लेते हैं और फिर समझते हैं. Right. What will happen is, let's say अगर ये एक range है 0 to n, right, which is actually the range of the entire array, right? So what can simply happen here is लेट्स से दिस इज़ द वैल्यू ऑफ मिड ऑफ द इंटायर एरे, राइट. और आपको क्या निकालना है, आपको ना रेंज है s, e, राइट. दिस इज़ अ रेंज जिसका आपको निकालना है. नाउ व्हाट यू विल डू इज ऑन द लेफ्ट साइड आपको इतना आंसर चाहिए, करेक्ट, एंड ऑन द राइट साइड आपको ये आंसर चाहिए, करेक्ट. दैट इज़ व्हाट द कॉन्सेप्ट इज. नाउ आप क्या करोगे, फॉर दिस रेंज यू विल फाइंड द मिड, करेक्ट. आप इस रेंज में जाके मिड निकालोगे, लेट्स से वी कॉल इट मिड 1, राइट. एंड फॉर दिस रेंज ऑल्सो आप मिड निकालोगे विच कम्स आउट टू बी मिड 2, करेक्ट. अब आपको क्या चाहिए, अगेन ये पार्शियल ओवरलैप का केस है कि भाई आपकी नोट तो ये रिप्रेजेंट करती है पूरा, और आपको कितना चाहिए, सिर्फ इतना आंसर चाहिए. तो मतलब आपको लेफ्ट साइड से ये आंसर चाहिए और आपको राइट साइड से ये आंसर चाहिए. सिमिलरली हियर आपको लेफ्ट साइड से ये आंसर चाहिए और आपको राइट साइड से इतना ही आंसर चाहिए. क्यों, बिकॉज दिस वॉज योर होल रेंज, है ना. अब आप फर्दर डिवाइड करोगे, देखो द मोमेंट यू डू दिस, राइट, आपने क्या किया, अभी 2 ही डिविजन्स करे. द मोमेंट यू डू दिस, ये वाला केस तो कंप्लीट ओवरलैप का हो गया, ये वाला केस भी कंप्लीट ओवरलैप का हो गया, राइट. व्हेन यू आर इन दिस पार्ट, दिस होल पार्ट जो आपका एक बचा है, आपको सिर्फ इतनी रेंज का आंसर चाहिए, करेक्ट. ये अगेन क्या होगा, आप मिड की वैल्यू निकालोगे, आंसर क्या सस्टेन हो जाएगा, सिर्फ एक साइड पे सस्टेन हो जाएगा. सो द ओवरऑल आइडिया इज कि आप किसी भी रेंज के लिए आंसर लो. लेट मी रिमूव दैट जस्ट टू गिव यू. द ओवरऑल आइडिया इज आप कोई भी रेंज ले लो, यू विल नेवर गो टू द इंटायर डेप्थ ऑफ द ऑल दीज नोट्स, राइट. आप हमेशा देखोगे यहाँ पे आप कोई भी रेंज ले लो, मैंने यहाँ पे क्या रेंज ली थी, 0,3, करेक्ट. तो यहाँ पे माई आंसर वॉज सिंपली अ कंप्लीट ओवरलैप हियर, और मैं यहाँ पे सिर्फ गई थी कहाँ पे, टिल द इंटायर डेप्थ ऑफ द ट्री. सो इन एनी केस यू विल नेवर गो टू ऑल दीज नोट्स, करेक्ट. आपको ये सारी नोट्स पे जाने की ज़रूरत नहीं पड़ेगी. यू टेक एनी टाइप ऑफ रेंज हियर, राइट. सो द आइडिया इज, ये 2 log n की वैल्यू क्यों होती है, बिकॉज एट अ टाइम आपको मैक्सिमम ट्वाइस जाना पड़ सकता है टू द हाइट ऑफ अ पर्टिकुलर ट्री. दैट इज द केस, एंड सिंस यू हैव टू गो ओनली ट्वाइस, द ओवरऑल कॉम्प्लेक्सिटी रिमेन्स log n. Does that now make sense to everyone? That maximum number of times आपको डेप्थ पर जाना जा सकता है, that means log n only, 2 log n only, and that is why the overall complexity is log n. मैक्सिमम टाइप डेप्थ पे जाना पड़ सकता है, दैट इज ओनली ट्वाइस. एक बार डेप्थ पे जाने में कॉम्प्लेक्सिटी लगती है log n, so the overall complexity is 2 log n, which is nothing but log n. राइट, ठीक है. अब हमने ये तो समझ लिया, राइट. इज एवरीवन हैविंग फन एंड अंडरस्टैंडिंग वट एवर वी आर डिस्कसिंग? मतलब आई होप दिस इज मेकिंग सेंस टू ऑल ऑफ यू एंड समथिंग यू फाइंड यूजफुल. मतलब आई डोंट वॉन्ट टू जस्ट keep on teaching even if you don't feel like you're not being benefited from the classes that I am taking, right? I hope everyone feels that they are able to make out something from what we are learning. Right, just something that I will put forward, right? Something of an idea that I will give to all of you is that to make sure, like I saw many students asking this doubt in the YouTube chat as well, that they wanted to have a better grasp on just not on one topic but on more topics, right? So I'll just give you a quick idea here, and a brief thing that I wanted to say is that CodeChef and Unacademy is actually going and organizing this structured learning program where we are starting batches exclusively for the students who take part in this particular program, and that batch is starting from 14 December, right? Where we will have a structured learning starting from the very basics to the advanced structures, right? There's going to be a highly competent instructors who will be teaching as a part of these courses and these batches. So we don't have I don't say we don't have any unstructured part. We're going to have, let's say for a long period of time, for an over a year period, I think हम एक structured learning follow करेंगे, right? जिसमें हम start by from the very basics. We'll start with very small topics like flowcharts and everything, and we'll go till the very end, till the advanced structures, right? So that is why if you want, if you're interested in getting placed in one of the FANG companies, or to create your own tech company, or something that you feel is useful for this particular point of time to land a better job, then definitely I would suggest you to take part in these courses. It's going to be a very I would say organized way, taught by some very very, I would say, highly competitive technical minds who have been teaching for a very long period of time, right, and who have a lot of teaching experience. So if this is something that interests you, right, where also we are giving a CodeChef certification also at the end of the year, right? And if you'll go and check out the prices of this course, you will see that the expenditure is actually around 90 rupees per day, right? Which is actually not a very big amount if you're willing to take that extra, if you're willing to walk that extra mile to make sure to improve and hone your skills in that particular aspect. So if you want to get very competitive in competitive programming, if you do wish to land a better job by having a structured learning, because I see many students facing that issue where they feel that they want to learn and they do have the right set of, I would say, mindset, but they lack the right resources and the right structure to go about it. So if you feel that that is something that interests you, please go ahead and check it out. The batches are starting very soon, and if you want to take part into it, please go ahead and do that. If you have any queries, please feel free to reach out if any clarifications you need on any manner. Like I said, the classes are going to be interactive like we are teaching, and it's not going to be just 3 to 4 classes. For each topic, we're going to have long classes which will work and which will actually help you get more into in-depth on these particular topics, right? We also have structured courses, so we'll give you practice questions also to practice and get a better idea about all these things, right? Like I said, both the topic wise and structural wise, we'll be moving from the very basics. If you want to learn in Java, C++, Python, any language that you want to start with, right, and we'll go till the very advanced topics, right? So we'll help you get all the prerequisites. We'll also help you interview preparation and solve a lot of questions in that manner, so that you get prepared for the specific companies that you are aiming for. Right, this is the price panel that you can check out, right? You can use my referral code as well if you want to get further discount for the 10% discount on the courses, and you can check it out on the website. We do have teaching assistance platform as well, where you can have a doubt clearing session, and also, like I said, practice problem sessions where we will give you some problems specifically to practice, right? Just something that I wanted to put out there, because many of you were asking that question of how exactly we can practice more and more questions, right? So that is one way we all can do that, right? Now jumping back to the part again where we will discuss like we know how exactly how we are going to build the segment trees, right? I hope with that knowledge in the picture सबको पता है कि segment trees कैसे build करना है, right? Segment trees पे कैसे queries करनी है. But now comes the part कि हम actually implement कैसे करें, right? How exactly to implement a binary, or I can say a segment tree, right? So let's take a look here how exactly we are going to do that. उससे पहले एक काम करते हैं. Let's first try to see how to represent, let's say, a balanced binary search tree in an array. ठीक है, ये करते हैं. Let's see हम इसको कैसे represent करेंगे in an array, right? So the idea is, अब यहाँ पे balanced binary search tree है, तो it binary tree है, तो it will look something like this. Let's not do search tree, let's just do balanced binary tree. और आपको इस ट्री को ना एक array में स्टोर करना है. Correct. So what you can do is, you can basically store this in a level order traversal kind of a format, राइट, वेयर यू कैन डू दिस कि पहले आप ए स्टोर कर रहे हो, फिर ए के दोनों चाइल्ड बी और सी स्टोर कर रहे हो, राइट. देन यू हैव बी के चाइल्ड दैट इज़ डी एंड ई एंड देन एफ, राइट. सो द आइडिया इज अगर एक नोड है विच इज़ प्रेजेंट लेट्स से एट द इंडेक्स आई इन द एरे, सो जो उसके दोनों चाइल्ड हैं, लेफ्ट चाइल्ड एंड द राइट चाइल्ड, दे विल बी प्रेजेंट एट 2i+1 एंड 2i+2, करेक्ट. अगर ए प्रेजेंट था 0th इंडेक्स पे तो इसके चाइल्ड 1 और 2 इंडेक्स पे प्रेजेंट थे, है ना, रिगार्डिंग दिस फॉर्मूला. अगर बी प्रेजेंट था 1st इंडेक्स पे तो इसके चाइल्ड प्रेजेंट थे 3rd इंडेक्स पे और 4th इंडेक्स पे, है ना. तो बी के दोनों चाइल्ड प्रेजेंट थे यहाँ पे, राइट. नाउ ऑल्सो जस्ट रिमेंबर वन मोर इम्पॉर्टेंट थिंग कि अगर यहाँ पे ई प्रेजेंट नहीं होता, राइट, इफ़ ई वुड हैव नॉट बीन प्रेजेंट तो क्या होता, यहाँ पे आइडियली आई वुड हैव रिप्रेजेंटेड एन एम्प्टी स्पेस टू शो दैट फॉर बी द चिल्ड्रन डी इज़ प्रेजेंट बट द राइट चाइल्ड ई इज़ नॉट प्रेजेंट, राइट. So that is how the overall idea will work, correct. तो ऐसे हम रिप्रेजेंट करते हैं एक बैलेंस्ड बाइनरी ट्री को इन एन एरे, राइट. दैट इज हाउ द ओवरऑल आइडिया वर्क्स. Vidushi says, ma'am, can I see all your videos without a plus subscription? No. Vidushi, without a subscription for the plus subscription, you cannot essentially attend the classes for the batches, right? I do take few classes, few online classes free from time to time, but for the plus subscription classes, for the batch classes, you will have to take a subscription and then only you can attend the classes, all right? Okay. Again, coming to the point that the overall idea for representing a balanced binary tree is in this way, right. We'll follow the same ideology for storing the segment tree as well, right. तो हम जो segment tree की construction यहाँ पे use करेंगे, which will be using a array only. So what exactly will happen here is, राइट, ये आपका एक एरे है सेगमेंट ट्री जिसमें आपको सारे नोड्स की रेंज का सम है वो आपको स्टोर करना है. वी आर कीपिंग दिस द साइज ऑफ द एरे एज 4n, राइट. दैट विल बी द मैक्सिमम नंबर ऑफ नोड्स इन अ सेगमेंट ट्री, राइट. आई वॉन्ट यू टू कीप दिस एज अ होमवर्क प्रॉब्लम एंड सी इफ यू कैन फिगर आउट द सोल्यूशन फॉर दिस, राइट. द क्वेश्चन इज़ वेरी सिंपल दैट अगर आपको एक नोड एक ट्री दे दिया है और एक एरे दे दिया है, राइट. आपको लेट्स से उसमें 6 एलिमेंट्स हैं, राइट. आपको बताना है व्हाट विल बी द नंबर ऑफ द नोड्स इन द सेगमेंट ट्री, ठीक है. द क्वेश्चन इज वेरी सिंपल दैट गिवन एन एरे टेल द नंबर ऑफ नोड्स इन द कंस्ट्रक्शन ऑफ द सेगमेंट ट्री, राइट. फॉर अ लूज केस और अ अपर बाउंड वी आर अज्यूमिंग इट टू बी ऑफ द साइज 4n, राइट. नाउ लेट्स से आपको इनपुट में ना एक एरे दे दिया है, राइट. यू हैव बीन गिवन एन इनपुट एरे और आपको ना उसकी सेगमेंट ट्री बिल्ड करनी है. और उस सेगमेंट ट्री को हम स्टोर कैसे कर रहे हैं, एक एरे की फॉर्म में. जैसे यहाँ पे हमने एक बाइनरी बैलेंस्ड बाइनरी ट्री को एक एरे में स्टोर कर लिया था, राइट. ओके, नाउ पहले एक काम करते हैं, लेट्स बिल्ड अ सेगमेंट ट्री. सो आई विल राइट द सूडो कोड हियर फॉर ऑल ऑफ यू टू अंडरस्टैंड. लेट्स से आई हैव टू बिल्ड the segment tree. अच्छा, before that मेरे को ये बताओ and please think very very properly and ideal manner when you answer these questions. What nodes do we fill first? कौन सी नोड सबसे पहले fill होंगी? Although we have already discussed this. To actually build a segment tree, leaf nodes, okay. The second question is what tree traversal we will follow here to actually build a segment tree. हमने ऊपर वो traversal किया भी था, एक specific तरीके का traversal. You have to tell me what that traversal is called. Not a right answer till now. सोचो, मतलब आई थिंक मैनी ऑफ यू आर जस्ट गिविंग रैंडम आंसर्स. जब मैं बिल्ड कर रही थी सेगमेंट ट्री को, राइट, जब मैं बिल्ड कर रही थी सेगमेंट ट्री को, राइट, द वे आई वॉज फिलिंग ऑल द वैल्यूज इन अ सेगमेंट ट्री वाइल बिल्डिंग अ सेगमेंट ट्री, राइट. Alright, I think we're still good to go. Perfect. I'll just quickly show my screen once again. Right. So the actual overall idea was that whenever you have a segment tree, right, whenever you have to build a segment tree, तो आपको हमेशा first you should know the value in the left subtree, right. आपको हमेशा अपने left child की value पता होनी चाहिए, right. You should also know the value of your right child. और जब आपको वो दोनों values पता होती हैं, then you fill the node itself, right. So what is this? This is a post order traversal, है ना. पोस्ट ऑर्डर ही तो है. पहले आप अपना लेफ्ट चाइल्ड को फिल करते हो, राइट, फिर आप अपने राइट चाइल्ड को फिल करते हो. जब आप दोनों की वैल्यूज फिल करते हो, उसके बाद आप फिल करते हो अपनी करंट नोड को. So in all these scenarios we can simply say that this was a post order traversal. Correct? That we are simply following a post order traversal to actually fill all the nodes. Correct. So we'll follow the same ideology here as well. Just wanted to put something out there so that we don't forget it. All right. So यहाँ पे ना I will put the range and so this is the range of the whole array. तो initially तो अगर let's say array में 6 elements हैं, तो मैं S में 0 भेजूँगी और E में 5 भेजूँगी. Correct, because that represents the entire range जिस पे मुझे segment tree build करना है, right. और this is basically I can say representing the index of ST array, right. अगर आपको अब एक नोड पता चल गई है तो आपको ये जो सेगमेंट्री एरे है उसमें स्टोर करनी है ना वैल्यूज़. तो दिस इज़ द इंडेक्स जहाँ पे आपको वैल्यू स्टोर करनी है. तो यहाँ पे मैं स्टोर करूँगी 0, करेक्ट, बिकॉज मुझे जो रूट नोड की वैल्यू है लेट्स से 0,6 था, उसका सम मुझे यहाँ स्टोर करना है ना. यहाँ पे भी बैलेंस बाइनरी ट्री में जो ए वैल्यू होती थी वो हमेशा एरे के स्टार्ट में होती थी बिकॉज वो रिप्रेजेंट करती थी द रूट ऑफ द ट्री. तो यहाँ पे भी जो ये रेंज होगी, रूट नोड यहाँ प्रेजेंट होगी और वो क्या रेंज रिप्रेजेंट कर रही होगी 0,6, राइट. ठीक है, तो अब मैं क्या करूँगी, सिंपली मैं यहाँ पे आगे पहले मिड वैल्यू निकाल सकती हूँ. Right, let's say the mid comes out to be SE plus by 2, S plus E by 2, right. अब can I not just do this कि मेरे को आगे जो सेगमेंट ट्री बिल्ड करना है उसमें एक साइड क्या होगी S कॉमा मिड, राइट, और ये वैल्यू प्रेजेंट कौन से इंडेक्स पे होगी 2 into NP plus 1. और मुझे जो दूसरा लाइट चाइल्ड, मुझे 2 चाइल्ड चाहिए ना, मुझे एक लेफ़्ट चाइल्ड चाहिए और मुझे एक राइट चाइल्ड भी चाहिए, करेक्ट. सो आई विल सिंपली से कि दूसरे उसकी रेंज क्या होगी, पहले की रेंज क्या होगी स्टार्ट टू मिड और दूसरे की रेंज होगी मिड प्लस 1 टू एंड एंड दैट विल बी दिस, करेक्ट. दैट इज़ द केस. नाउ जब आपको लेफ़्ट साइड का भी आपने सेगमेंट ट्री बिल्ड कर लिया है, आपने राइट साइड का भी सेगमेंट ट्री बिल्ड कर लिया है, तो आप क्या करोगे, सेगमेंट ट्री वाले एरे में करंट इंडेक्स पे क्या वैल्यू होगी, जो वैल्यू पड़ी है इन इंडेक्सेस पे. करेक्ट, that will be the value that will be present at the current index जो कि लेफ्ट राइट. तो देखो पहले मैं लेफ्ट साइड का आंसर ला रही हूँ, राइट साइड का आंसर ला रही हूँ, उसके बाद आई एम फिलिंग माई करंट लेवल, राइट. एंड द बेस केस तो काफ़ी सिंपल हो गया. अगर s इक्वल टू e हो गया है, मतलब मैं लीफ नोड पे आ गई हूँ, है ना. तो मतलब एट दिस पॉइंट मुझे np पे क्या प्रिंट करना है, जो कि इनपुट एरे में स्टार्ट में पड़ा था, है ना. देखो यहाँ पे अगर आप इस केस पे हो जहाँ पे स्टार्ट और एंड दोनों सेम है, मतलब s इक्वल टू e है, तो आप कौन सी वैल्यू प्रिंट करते हो जो कि एरे में आपको 0th इंडेक्स पे दी थी, दैट इज़ 1, है ना. अगर आपको वैल्यू फिल करनी है 4,4 की, तो 4,4 में क्या है, स्टार्ट इज इक्वल टू एंड फॉर अ पर्टिकुलर रेंज, और आप वैल्यू कौन सी डालते हो जो कि 4th इंडेक्स पे थी. तो वील फॉलो द सेम आइडिया हियर एज वेल. इफ़ दिस वॉज द इनपुट एरे जिसके ऊपर आपको सेगमेंट ट्री बिल्ड करना था, राइट. एंड you will simply do this and you will return. This was the implementation. Is this clear to everyone how you are going to build a segment tree? Sanket, do you think that is possible? Can you get multiple segment trees? Is there anything called multiple segment trees? मतलब अगर आपको एक एरे दिया हुआ है और अगर आप इस तरीके से बिल्ड कर रहे हो, कैन यू गेट दैट. लेट्स से आपके पास सेगमेंट ट्री ऐसे था 27, 10, 17, 4, दिस इज़ अ सेगमेंट ट्री. ठीक है, अगर आपको इसको एरे की फॉर्म में रिप्रेजेंट करना है, दिस इज़ हाउ यू विल डू दिस. तो यहाँ पे एक नोड होगी 27 विच विल रिप्रेजेंट द रेंज 0,5. यहाँ पे इट विल हैव 2 चाइल्ड 10 and 7 जो कि रिप्रेजेंट कर रहे होंगे 0,2, 3,5. यहाँ पे 10 के चिल्ड्रन आएंगे विच विल बी 4 and 6. फिर 7 के चिल्ड्रन आएंगे 17 के चिल्ड्रन विच इज़ 10 and 7, राइट. देन यू हैव चिल्ड्रन फॉर 4 विच इज़ 1,3 एंड द चिल्ड्रन फॉर 10 विच इज़ 0,10. Correct. This is how you can simply build the whole segment tree. Just quickly tell me if this is clear or is there any doubt in this. Akash, NP is basically the pointer where you have to fill the value in the segment tree array. ठीक है, आपको ये array fill करना है ना, तो आपको कौन सी वैल्यू कौन से इंडेक्स पे डालनी है, आपको रूट नोड वैल्यू कौन सी डालनी है, 0 इंडेक्स पे डालनी है ना. तो आपने यहाँ पे सिर्फ 0 पास किया, ठीक है. और आपको 0th इंडेक्स पे क्या वैल्यू डालनी है, जो कि 1 इंडेक्स और 2 इंडेक्स पे प्रेजेंट है, करेक्ट. सिमिलरली जब आप रिकर्सिवली आगे बढ़ोगे तो फर्स्ट इंडेक्स पे क्या वैल्यू डालनी है, जो कि सिंपली 3rd और 4th इंडेक्स पे प्रेजेंट है. तो दिस NP इज़ बेसिकली अ पॉइंटर जो कि SP एरे के ऊपर आइटरेट कर रहा है और आपको बताता है कि आपको कौन सी वैल्यू इस एरे में कहाँ डालनी है. तो टेक्निकली NP एरे पहले यहाँ पे था और ये एरे इस ST एरे के ऊपर इस ऐसे आइटरेट कर रहा है. Right. Okay, now first let's complete this part, right. Let's take an IDE and see how we are actually going to build the segment tree on that IDE. I'll make a new package. let's say you have an array, and for that array you have to build a segment tree. Array size of the segment tree array, Rahul, that is going to be 4 into n. 4 times the size of original array. We are taking I think an upper bound here. There is a mathematical formula for that. Why exactly is the term 4n, and how many and what exactly will be the array size for a particular segment tree, right? That is definitely not the course. I would say that is not in the scope of this micro course, because that is that involves a lot of maths. So for the time being, we are going to assume that the size is going to be 4 into n. You can definitely Google it out as well if you want. Right? So the overall idea is that if you have n values in the original array, right, the maximum number of nodes in the segment tree array cannot exceed 4 into n, right? There is a mathematical proof for that as well, right? If you want, you can check it out. That is not going to be covered in this course, but yes, there is a reason for that. Alright, now simply call the build function. Sorry, let's say I pass the array. This is the original array ARR. जो array fill करना है, that is this. Range pass करिए, that is going to be this, and ये index जो value fill करनी है. Correct? Let's say this is the start of the range and this is the end of the range. Let's say this is the index. SI represents the index जहाँ पे actually value हमें डालनी है. तो leaf node का case तो we already know that if the start of this range is equal to the end, तो मतलब you have to put the value. So SI will be equal to ARR of SS, है ना? ये जो index है, like I said, SI, it just iterates over the segment tree array, correct? And then you simply return from here. Now what you have to do is, let's say mid is equal to SE plus, right? This is what the mid formula is. You can just simply do SE plus SS by 2 as well, और recursively आप वही चीज़ कॉल करोगे for the left subtree, right? अब left subtree में ये तो पैरामीटर सेम रहेंगे, the only parameter is the range. अब range क्या हो गई है? SS till mid value, right? और वो value जो डालनी कहाँ है, जो इस range का आंसर है, जो SS से mid का आंसर है, वो exactly आपको रखना कहाँ पे है array में? वो आपको रखना है यहाँ पे, ठीक है? तो ये एग्जैक्टली हम यहाँ पे कन्वे करना चाह रहे हैं कि जो भी आंसर होगा फॉर द रेंज SS टू मिड, उसको आप प्लेस कर दो इस इंडेक्स पे, करेक्ट? यही मैंने क्योंकि फॉर्मूला आपको बताया था फॉर प्लेसिंग दी वैल्यूज इन एन एरे. नाउ द अदर रेंज इज मिड प्लस 1 टू SE, है ना? SE हम डिवाइड करेंगे और इस रेंज का जो भी आंसर होगा वो आपको प्लेस करना है SI इंटू 2 प्लस 2, ठीक है? दिस रेंज पे आपको, एंड हियर आई कैन सिंपली से, जब आपने दोनों साइड का कर लिया है, सो हियर आई विल सिंपली डू SI इंटू 2 प्लस 1 पे जो भी था, मतलब लेफ्ट साइड का जो भी आंसर था. नाउ हियर SI इंटू 2 प्लस 2. जो भी राइट साइड का आंसर था आप अपने में रख दो, you simply return. This is how you will build a segment tree, right? प्रिंट भी करके देख लेते हैं. Right, let's quickly see how will that work. ठीक है, देखो अब यहाँ पे सारी वैल्यूज़ का सम कितना होगा. 11 + 9 is 20, then we have 27, then 27, then we have 32, 35, 36. तो सारी नोट्स का सम कहाँ है, यहाँ पे है. ये 9 क्या रिप्रेजेंट कर रहा है, द सम ऑफ दिस रेंज, दैट इज़ 135. ये 27 क्या रिप्रेजेंट कर रहा है, द सम ऑफ 9, 11. करेक्ट. अब यहाँ पे ये 9 के 2 चाइल्ड हैं, है ना. 9 ये जो ये वाली रेंज थी 135, उसको मैं फर्दर डिवाइड कर सकती हूँ. एक रेंज 1, 3 जिसका आंसर यहाँ है, और एक रेंज है 5 जिसका आंसर है यहाँ. नाउ फॉर 27 जो कि इस पार्ट का सम था 7, 9, 11, मैं इसको भी डिवाइड कर सकती हूँ. आई कैन फर्दर डिवाइड इट इनटू 2 पार्ट्स, राइट. I can further divide it into 2 parts, saying that one part is 7, 9 जिसका सम आया है 16, the other part is 11 सम जिसका आया है 11. Correct? And this is how you can fill the whole segment tree here. तो आपने सारे segment tree को you have represented it in the form of an array. Is this part making sense to everyone? Whatever we discussed. That is how you are going to build a segment tree, right? I hope the overall idea was clear to everyone, that how exactly segment trees are built, right? What I would want you first to try is, I have told you kind of a upper level view of how the segment tree will look like, what will be the recursive code look like. Now take that knowledge home, see if you can use that concept to basically see if you can solve the queries also of how you're going to do a range sum query and an update query, right? Try solving that part, see if you can figure it out. Otherwise we'll definitely write the implementation for it also in the next class, right? Yes, Mayank, you can do that. For a no child you can simply put a 0. You can put any special character also to denote that, but 0 also works, राइट. बिकॉज एसेंशियली हम एक नोड से एक रेंज ही रिप्रेजेंट कर रहे हैं, तो 0 बेसिकली रिप्रेजेंट बोथ थिंग्स. करेक्ट. ऑलराइट, सो आई होप द सेशन वॉज यूजफुल फॉर एवरीवन. यू वर एबल टू learn something new today, and in a more, I would say, a briefed manner, right? I tried to explain that concept from the very scratch, so you get the overall idea that how things are working, right? Please do join in for the second class as well that we have. I'll just follow up on that concept and we'll solve a lot of problems, right? Aaj ki class was very theoretical. We tried to learn everything from scratch of how exactly and what exactly are segment trees. In the next class we'll solve a lot of problems from beginner to medium level problems and try to build that concept there, right? हम सेगमेंट ट्रीज बार बार नहीं बनाएंगे. सेगमेंट ट्री काफ़ी ईजी होता है. सेगमेंट ट्री को एक बार बनाना इज़ इम्पॉर्टेंट, उसके बाद यू कैन फॉर एवर मेक इट. टू यूज सेगमेंट ट्रीज टू सॉल्व डिफरेंट क्वेश्चंस, वो एक इम्पॉर्टेंट कॉन्सेप्ट होता है विच वी विल सॉल्व ऑन अ लॉट ऑफ क्वेश्चंस इन दी नेक्स्ट क्लास, राइट? ओके, थैंक यू एवरीवन फॉर अटेंडिंग and hope you had a wonderful session, and I'll definitely meet you in the next class, that is I think on Sunday, right? Sunday 1 p.m. We learn more concepts in that class. Thank you everyone. Bye bye. Good night.